being presented here today. So welcome to our webinar on residential ESS and UL 9540 certification summary. This is co-presented by Discover Battery and Schneider Electric. And our presenters today, I'd like to introduce as David Norman of Discover Battery, Jack Croce, who's the Director of Commercial of the Solar Business with Schneider Electric, and Eric Benson, who's a Senior Sales Application Engineer with Schneider Electric as well. My name is Matthew Campbell. I'm the Director of Marketing with Discover Battery. And without further ado, I will pass the presentation over to you, David.
Thank you very much, Matthew. And thanks to the Schneider guys, Eric and Jack, who I know very well. Appreciate you participating in this. And it's nice that we have such good collaboration between our companies. The topic of UL 9540 has been a fairly hot one over the last while, and depending on the geography you're in, or even sometimes the county you're in, within a larger state sort of realm, I guess, adherence to this and the explanation and understandings of this have been not well communicated and such. What we're here to do today is to explain to you what the Schneider and Discover organizations have done jointly to basically achieve the UL 9540 certificate. We're going to talk to you a bit about when it's required, and then also how you can, what kind of documentation and things we have for you to help you get through that permitting process. So first of all, what is it? It's a safety standard. Basically, it's there to try and add an additional level of security and assurance to you and the homeowners that you're selling to, such that they can be assured that the power electronics they're installing and the battery system that it goes along with it have been tested basically together to collaborate, and that it is an additional layer of safety over and above that. You know, and Jack probably knows this better than anybody on the call today, but in terms of geographies that are enforcing this, you're seeing it all throughout California now. New York State is, you know, very high on this. I'm actually hearing about it recently in Texas being enforced. Jack, any others you can think of offhand that are really high concentrations?
Yeah, most of the Northeast, it's a hard requirement, and it seems like a lot of other states are looking at it. So I think Colorado is another state that is enforcing it as well. And then there's just different, you know, utility jurisdictions that are requiring it throughout the United States right now.
Yeah, very much so. So UL 9540 was first brought in and referenced as a part of the NEC 2017. Obviously, that's advanced since then, but as we all know, AHJs in certain counties refer to the NEC of different years and different vintages, depending on how up to date they are in their training or what they've been, you know, told to enforce. But essentially, it came into being and was reflected in NEC 2017 for the first time. And it will affect any permitting for residential solar plus storage systems where it is being enforced. Unfortunately, again, with electrical code, it's not a universal, and some of you will have to play with this, but that's some of what we're going to be giving you guidance for and tools for. Is if you do see this permitting as a necessity within your local region, that you'll have some information from us that can guide you through that and help speed you through that. Again, it's an additional supplementary safety standard to reduce risk. And basically what it does is it, you know, we'll go through some of the testing process and the like that's involved in this, but it is a standard to ensure that there's compatibility in operation and more specifically, fail-safe operation of the different safeties mechanisms within both the power electronics and the battery, such that there are no, you know, U-tubable events, if you will, and you know, again, your customers are provided with a level of insurance, especially given some of the you know, how would I say this, the variance in understanding of what lithium batteries are for these environments, and you know, that all lithium batteries are lumped together, be it from your iPhone or be it in your electric vehicle or home ESS system. To be clear on this, there is no self-certification or self-declaration path for UL 9540. In other words, as a battery manufacturer, Discover Battery can't simply perform some tests, read the standard, and then issue a declaration that says, you know, we meet or compliant with UL 9540. It's an actual standard that has to be generated and provided to you from an NRTL, which is a nationally recognized testing laboratory. examples of which are ETL, UL itself, CSA Canada, Intertech. Any of those nationally recognized testing laboratories can test to this standard, and it does require both documentation, but also failure analysis thing from the power electronics manufacturers as well as the battery manufacturer. Matthew, would you mind just quickly, so we can give a bit of reference here, switch to the certificate of conformance screen so these people know what they're going to be looking for?
Sure can. Pardon me here. Need to shrink this down. There you are.
Yeah, so as you can see here, certificate of compliance is a formal written document that certifies from the issuing body. In this case, it's CSA Group, and I believe it was CSA Canada that we went through this with. But it's applicable to Canada, US, and any other place within this jurisdiction. But essentially what it does is it provides you with documentation that you can provide to an AHJ that as long as your system you are installing with Discover Batteries and Schneider Electric Power Electronics fits within the matrix that we're going to discuss here of possible combinations that fit within the standard, then you have documentation right at your hand that can basically say that this satisfies the UL 9540 requirement if they are enforcing that in that jurisdiction. So back to the PowerPoint, Matthew. Yes. Okay. So, what is the process for getting UL 9540 and what testing is a part of this? So the table stakes for discrete components, and it would be slightly different if you were making a combined system that was a combination battery plus inverter charger, because you'd be basically having it all in one house. But for a couple organizations like Schneider Electric, who makes power electronics, and Discover, who does lithium energy storage batteries, what it is, first, the table stakes are that the inverter meets the appropriate standard for power electronics in a residential stationary application. And that's specific to that requirement for power electronics. It's UL 1741 with the SA standard. Okay, the battery standard for stationary energy storage is UL 1973, and those are very different in terms of their testing. Obviously, a battery is not going to be tested on things like transferring and power and load controlling and this kind of thing, and neither is an inverter going to be for overcurrent shutdown of a BMS. But those are sort of table stake standards that get you to the level where you can then go and collaborate together to get and achieve UL 9540. So once you have those and you bring those that documentation and all the safety test reports that go along with getting those regulatory approvals to your AHJ, or pardon me, to your NRTL, again, UL, CSA, TUV, etc. What they then ask for is system level safety checks, where they do some testing based on the collaborative energy output and controls and safety mechanisms of both the inverter charger system, any of the disconnects, overcurrent disconnects and otherwise, and the battery itself, the BMS's internal intrinsic safety protections. So through this, they go through a detailed FMEA. And for those of you who haven't been in electronics manufacturing, that's a failure mode effect analysis process. And what they do basically there is they look at all the potential fail points and possible failures that could exist or coexist between power electronics and battery, assess them, stack rank them based on priority and potential for threat. And then basically you go through a raft of testing to see what happens. Do these internal protections for either the battery's BMS or the battery itself or the inverter, do those cascade the way they should in collaboration with the power electronics and battery, and do they provide a safe outcome that is expected? Okay, so the FMEA process is it's very exhaustive. They ask for a comprehensive tests to be performed and the results to be shared. And ultimately, at the end of that, if they are satisfied with the results and the protections of both devices are doing what they should, you can be issued your 9540 certificate. Now, there are virtually innumerable, I would assume that most of you who are on this webinar today are familiar with the collaboration or the capabilities of Discover Batteries with Schneider Electric Power electronics, XW Pro specifically, over, and collaborating over ZAMBUS. Okay. That said, there are virtually innumerable combinations of either XW Pro and power electronics like charge controllers or AC coupling, and our battery combinations that can be done there. Specifically though, UL 9540 puts a cap on the energy storage component at 20 kilowatt hours. Okay. And then on the inverter side, mainly because of sizing limitations on our battery in terms of current handling, it puts a limit within these parameters on 2 XW Pros. Is that correct? We'll see the matrix here in a second that Eric's going to go over.
That's correct.
But it's basically the combinations of our batteries with Schneider XW Pros that fall within the parameters of 9540 and within the operating limits of our respective power electronics and battery. Okay, so what we'll do, actually, we're going to have a quick Q&A break here just to get any questions about what UL 9540 is. If any of you have questions that are in attendance for the webinar, you can either drop them into the chat, or I believe there's an actual raised hand. You
use the Q&A. There's a Q&A or the chat function.
Yeah, you can, and you can drop your questions in there if there's anybody that's unclear about 9540 itself.
So David, while those are loading up, I have a question. What certification would cover battery banks that are greater than 20 kilowatt hours?
So greater than 20 kilowatt hours, I mean, either A, you have regional exceptions, as we were discussing this morning in the document that you sent over, right? There are certain regions and AHJs, particularly ones where they have a higher concentration or need for energy storage and it's not as novel, where they might have a regional exception to the 9540 in terms of either increasing capacity or allowing multiple systems to be installed in the same location, as long as those systems are made of building blocks that are 9540 compliant. And then the further path is on the battery side, and that's basically to, rather than meet the 9540 standard, which requires partnering with a power electronics manufacturer, we could have an independent UL 9540A certification on our battery, exactly, which we intend to on all future generations of our residential energy storage products, as soon as probably of January of 2022. But UL 9540A starts from the cell design up and your cell certification up right through the manufacturing process. It's a more exhaustive extension of UL 1973 that it's there today. That's a battery standard only, and that allows for basically doubling of that size in a residential system and quadrupling up to 80 kilowatt hours in a commercial system.
Yeah, and follow up on that, David, too. We're seeing the rules for 9540 are not being universally applied. It's still such a new standard. So, below 20 kilowatt hours, no questions asked, shouldn't have no problem getting approval from the AHJs. Above 20 kilowatt hours still might be possible. We have a lot of systems installed with Discover above 20 kilowatt hours, but you definitely need to clear that with your AHJ first.
Yeah, and further to that, again, some of the tools we have built in, the links we have built into this presentation, which you'll get by email afterward, should help guide you there. The table stakes for this is that you have a building block that's 9540 compliant. And then after that, whether it's installing multiples of that building block at a given residence with some kind of a space separation requirement, or whether it's simply that, an expansion of that makes logical safety sense to the inspector at that particular site, it's really up to you to sort of get that work done ahead of time, provide the documentation to the inspector you'll be working with, and have them, give you guidance prior to, you starting to fully design it and permit the system.
Yeah. Matthew, I just saw a couple of questions.
Yeah, there's a couple of questions have come in. I was just waiting for you to finish up. One is, there are two great questions. One, are solar charge controllers included in the standard?
Well, why don't we do them together? Because the second question also ties into that. And, can you do AC couple? And so the answer to that question is, what we did is we got this qualified as a system, which is the XW Pro inverter and the Discover battery. We did not use charge controllers or a grid tie inverter. And the reason for that is this allows us to do either AC or DC coupled system. So an AC coupled system with, a string inverter, micro inverter, whatever, that works fine. You can also do a DC coupled system with our charge controllers and have UL 9540.
Yeah, Matthew, just while we're answering that and to extend that, why don't you skip forward to the next slide and maybe give some context there? Okay, so this is just to preface this before we go into detail with it. I don't want to steal Eric's thunder on this one, but this is basically a printout or extension of page 2 of the certificate of conformance that we had for the UL 9540 combinations between Schneider Power Electronics using the XW Pro and our battery combinations. That said, I mean, you can see even with, 1 or 2 inverter chargers and having 2 of our battery models and allowing you to go anywhere from 7.4 kilowatt hours up to 20 kilowatt hours, there's already a lot of combinations within this. If we were to have brought on differing string inverters or micro inverters to combination in this and such, or we were to bring on the combinations that were possible from adding on any one of the 3 MPPT models from Schneider Electric that are, work on ZAMBUS and are part of their offer, the permutations just become virtually unlimited. So when they're adjudicating UL 9540, being specifically that charge controllers are outside of the interactivity of anything to do with a home electrical system, they're just directly tied into the batteries themselves as a charge source. There's really no need to include charge controllers there. So, I mean, the extrapolation from that is you basically have unlimited flexibility in what you want to do for solar harvest on the DC coupled side, provided you got enough modules and enough storage capacity to make it practical. You're really untethered from that on the DC side. You will always be tethered or limited somewhat on power electronics from a string inverter or micro inverters on AC coupling, because ostensibly the proportion of solar you can have is directly related to the size of the power electronics in your hybrid inverter. And, a 6.8 kilowatt inverter charger can only have so much backfed AC into it. So it's limited that way as well. But they are isolated systems outside of the standard. And regardless of your choice, it should be a zero impact to your AHJ. Eric, with that, maybe I'll hand over the combinations to you and you can kind of review these different permutations.
Yeah, thanks, David. So basically what we're seeing here is the tested configurations that are pairing different numbers or quantities of XW Pro 6848s with different quantities of the Discover batteries. They have the 6650 and the 3000 model. So the 3000 is roughly half of the kilowatt hours of the 6650. So as you can see from the chart, we can go up to 3 of the 6650s for a 20 kilowatt hour energy storage system with up to 2 XW Pro 6848s, which would give you a nominal 13.6 kW at 25C continuous power output with up to 24 kW of surge capability. These batteries are very well suited for use on a one-to-one basis with XW Pro. These batteries can easily handle the continuous current rating and easily handle the surge rating. So yeah, we've been partnering with Discover for many years now. Most of you are probably well aware of that. It is or has been a direct ZAMBUS compatible battery. That's probably been one of the most popular aspects of the pairing of our 2 products together, is the plug and play compatibility. So if anybody has any questions about this chart here, I'd be happy to answer those.
Yeah, and you can find that chart on the certificate of compliance, so you don't have to memorize it.
Yeah, it's page 2. Sorry, we didn't show it initially, but it would outlay all the different combinations, permutations.
So a couple of questions have come in here. One, I think we've just looked at, and I can just go back to that slide, was the largest system available with 9540 then is the 4248 6650. And if I point to it on the chart, I believe it is the 20 kW is the largest.
That's right. Mm-hmm.
Yes, and again, reiterating this, 20 kilowatt hours is the standard. It's written into the standard for UL 9540. So it's impossible to get 9540 with greater capacity than that. Now, in terms of permitting, again, Jack's referenced it, and we've definitely seen this in the field. Depending on the inspector and their understanding of these combinations and the like, quite often they'll say, okay, well, if 2 inverters and 20 kilowatt hours of capacity meets 9540, then 4 inverters and 40 kilowatt hours, provided it, is breakered and protected properly, should also meet that. Again, that is the interpretation locally, and it's not written into the standard. So all we can show here in the standard itself is the limitations as written in the standard.
Cool. So another question here is, as an installer, how do I get my power or amperage? For example, he's looking for an off-grid requiring 60 amps of 220.
60 amps AC at 220 volts AC is that?
That's probably it, Eric. Yeah.
Yeah. So each XW Pro can provide up to 28 amps of continuous power at 25C, and that's at 240.
Yeah, and that's continuous, right? So I
That's
mean, depending what
continuous.
you need for 60 amps, if the 60 amps is a momentary load,
Right.
probably suffice with less than that. Otherwise, you're basically at that requirement with 2 inverters.
Yeah, and if that's just an inductive motor that's starting, then you could probably cover it pretty closely with 1 inverter if it's just a short duration.
Yeah.
All right. Got another question here on lead times for equipment. So,
Now for something completely different.
totally different, but what are the lead times on each of the equipment types? And, is there a bottleneck here?
I'll speak on the Schneider side. So we actually did a really good job of planning this year, and we have a lot of product in stock. We should not have any problems through the rest of this year. The global supply chain is a mess for everybody right now, but right now we have a really good stock situation. And like I said, should through the end of Q4 for sure.
From the Discover side, I would suggest that if you're an installer and you're purchasing from any of our major distributors, the Amorescos, the CED organization, AEE Solar, any of the large wholesalers and such, you should have no issue sourcing the batteries at this point in time. I will say that as opposed to the Schneider Electric guys, and I have some background there as well. But we have an additional limitation in terms of cargo space on ocean transport, and that's what we have to. All of our batteries are dangerous goods, or DG shipments. That said, securing boat space at this point in time for ocean transport has been a challenge. Fortunately for Discover, I mean, outside of just the lithium business that I focus on here in solar, we're shipping 150 to 200 containers a month of lead acid batteries from Asia to North America. So we have some pretty good contracts and some pretty good priority there. Again, all I would suggest to you is, and this would go for anybody in the electronics business or electrical business at this point in time, as soon as you have a job or you have a schedule for a job, book your component orders and get those in the system, because whether it's first come first serve basis, or even just getting the stuff in early in terms of managing terms and things, you're far better off to have the product secured and early than you are to be scrambling to reconfigure all of your schedules and subsequent jobs as you go along. At this point in time, though, we have batteries in stock, not to the level I would like or am comfortable with, but we are stocking all of our majors fully and fulfilling orders.
There's a few more questions here. Is ZAMBUS spec published, and how does one go about integrating directly with ZAMBUS comms?
So ZAMBUS is a peer-to-peer network, and it is plug and play. The legacy Discover AES batteries had a direct ZAMBUS port. They're moving toward the Discover Link. David, if you wanted to comment on what they can look forward to with regard to future integration with the XW Pro.
Yeah, and just maybe just touching on ZAMBUS. I mean, ZAMBUS is a proprietary, CAN network based on J1939 COM standard. If you wanted to do a full integration like we do over ZAMBUS, where we emulate several devices, I mean, that's a months-long process. I mean, when I was at Schneider, that's when we embedded the Discover firmware engineer in the software department or firmware department to sort of complete that and get coached through it. If your question is just simply about connecting our batteries and having them operate in a Schneider Electric power electronics ecosystem, I can we'll follow up with some of that, and I've got some documentation to support that shortly.
Well, yeah, one further point on this is we no longer really support working, setting up direct ZAMBUS communications. If you're looking to tie a device, or some sort of communications with us, we have Insight Home and Insight Facility, which are edge devices, and you can communicate with those either on CAN bus or on Modbus. It's a lot simpler, a much quicker process.
Yeah, and it's a public PGM and Modbus maps too, right? So if you, as long as you're familiar with that stuff, the hooks are in.
Exactly. You will need a Modbus master to read and write to the individual registers, but a lot of OEMs are doing that. But yeah, as David mentioned, ZAMBUS is a proprietary network, so there won't be any direct communication. That's handled by converting to TCP over IP through the edge devices Jack mentioned, which is Insight Local.
Yeah, so maybe let's go on to the next slide here and capture.
So there's a few more questions here if we've got time to tackle those. I got 4 more. So this is a question here, I think, on the max size. So 20 kilowatt hours is over how many continuous hours when you measure?
So 20 kilowatts for 1 hour, or 1 kilowatt for 20 hours?
It's load dependent.
Yeah.
Yeah.
Okay. How many VAC load out per 6848?
It's they're 12240 by default. They can be configured for 120 volt for 3-phase operation, which would require at least 1 inverter per phase, and we can scale up to 2 inverters per phase. So that would be a 40 kW or a 60 kW system, 3-phase 12208.
Okay, and I got two more, and then we can move on. How close is the whole home backup on a 200 amp panel can the biggest configuration achieve?
It really depends on what the loads are. It really depends on what the loads are. And if you have really high continuous loads, then you're going to have some sort of controls at that main panel.
You hook up your baseboard heaters and you got problems, or your electric stove, and you're going to have problems. But if you simply want to run lights, internet, and cable, let's say for entertainment sort of purposes, or running a home office, I mean, God, 20 kilowatt hours, you can run a long time. It really, and the beauty with these too is, right, I mean, if you add a solar component to it, you can run virtually indefinitely. I mean, this is, as soon as the grid drops off, ostensibly you're an off-grid home. And these are off-grid inverter chargers and off-grid batteries. So as long as you've got a source to harvest electrons, your time, to your question, is indefinite. Add on a auxiliary generator to that fold, and you need to never have the utility come back on.
Yeah.
Okay, we've got 2 more questions here, but I'll limit it to 1, and we'll save the other one to the end. Because I think it's more apropos around actual product questions as opposed to 9540. So the last question here is, why the 20 kilowatt hours? Were there any problems or anything that occurred, or why limit the standard to 20 kilowatt hours?
I can answer that for you, and the answer is that it was an arbitrary metric with a round number on it. Again, relative to a lot of these things that you would see in residential electrical, like AC load centers or, transfer switches and things like that, residential energy storage systems are relatively new. In order to look at this, and then you've got multiple lithium chemistries, and you've got a bunch of market perception too that is indifferent. When you say lithium battery, I've got a lithium battery in my iPhone that happens to be, cobalt driven. There's lithium batteries in your electric vehicle that are usually magnesium based, and then you've got the LiFePO4 batteries that we use in our storage systems. And lithium is a very broad category. To that end, 20 kilowatt hours in my mind from discussions I've had is arbitrary. Although, if you compare it to standard lead acid systems that maybe preceded that, that's the equivalent of 40 kilowatt hours of lead acid storage. So, could be seen as being a lot. Again, these standards are evolving. These standards for sizing are evolving, and it really depends on what you want to do. Off-grid homes, I mean, Jack and Eric, you can attest to this, but it's not uncommon at all to see 40, 50 kilowatt hours of energy storage in a residential home. If it's just for backup or for demand charge avoidance, then you really don't need much capacity. So it's kind of an arbitrary blend between those use cases.
Yeah, it's also going to be very AHJ dependent. This morning I was looking at city of Santa Rosa in California, and they're allowing 40 to 80 kilowatt hours of energy storage. And so, look, if an AHJ looks at this chart, they could safely come to the conclusion that the Discover battery with XW Pro could be used on a 1-to-1 basis or up to a 2-to-1 basis. So for example, it wouldn't be a stretch to say you could have 2 of these systems in a single residence to give you, 4 XW Pros and 40 kilowatt hours of storage. There's also other language. Bill Brooks has provided his own website called solsmart.org. That's SOL smart.org. And, it has permitting guidelines for energy storage systems. And it also has the 40 and 80 kilowatt hour limitations. So specifically in California for power safety, public safety power shutoff, I heard that a lot of HJs were allowing a doubling of the 2040 to 4080 as well. So it's all going to be AHJ specific as to what system sizing they're going to allow.
Yeah, and there are OEMs like within the PG&E territory. They themselves, as a utility, are allowing extensions to the 9540 limitations of 20 kilowatt hours to accomplish some of their own purchased and operated backup devices. Containerized systems that are basically sit within the grid to provide ostensibly off-grid power usage, and they've made exceptions to 9540 themselves for that. So it really is, again, inspector and AHJ specific for you in the field. 9540, the standard as written by Underwriters Laboratory, is very specific. It says 20 kilowatt hours, and that's what we have tested too.
Yeah.
Like everything in life, the world is shades of gray.
Yeah. Yeah. And this is a very much evolving standard as far as marrying UL 9540 with UL 9540A with UL 1973. There's a lot of things that are moving pieces and parts, and there's a lot of things even being changed with UL 1973 because there's some things that are kind of contradictory in the code. So I think it's just going to take a year or so for this to really flush itself out.
Yep. Next slide, Matthew. We're just going to go on a bit of the batteries, and I'll help with sizing there. So what I'm showing you here is the 2 batteries at present that we have within the UL 9540 listing. Most of you are probably familiar with the 7.4 kilowatt hour battery, which is the part number 6650 that we mentioned before. 6650 just happens to be the useful capacity, whereas 7.4 is the nominal capacity. That's why we can have 3 of these batteries and fit within the 20 kilowatt hour requirement. It's also no mistake why the batteries were designed at 6650. It is almost exactly 20 kilowatt hours. Common features between these batteries, they're all 1C continuous charge and discharge capable, meaning they're designed for high currents that would be required in off-grid or extended backup applications. In terms of inrush handling and surge capability, the big battery surges to 300 amps DC singularly. That all is linearly scalable. So if you add 2 batteries, it's 600 amps, 3 batteries, it's 900 amps. Both batteries allow for what we call link as a concept, closed loop communications with external power electronics, and I'll go a bit more into that in a second. When you do have link capability though, and we have a direct comms link between the batteries and the power electronics, we can do neat things like dynamic charge management, and you can push all the data and record all the data and logging, etc., at a system level view through Insight home facility devices and or the Insight cloud portal to access it remotely and look at system remotely. Okay, with the 3 kilowatt battery, the smaller battery we do not have a separate ZAMBUS channel built into the battery. So in order to complete or close the loop, if you will, with Schneider Power Electronics, you would add our link device and the ZAMBUS edge card, which basically just tells it what pinouts it's looking for and what language it's supposed to be speaking with the power electronics. In this case, it's ZAMBUS. We also can close the loop with other power electronics manufacturers, international major brands, essentially anybody that's on a sophisticated modern comms platform. Okay, and that's basically a quick overview for you of the 2 batteries that are fit within this standard. Matthew, next slide, please. So here's just a quick overview when we talk about closed loop communications, what it means. And essentially, I mean, you can recognize, and I apologize, this is an old image, so it still references the Connect COM box, which is about 3 revs behind now, my understanding. But you could replace that text with the Connect Insight or facility. But ostensibly, what it means is our battery is just acting as another node on that network. Okay, if you were to have multiples of our battery on that network, we would be basically ganging those together on the other CAN channel that's native to the BMS, and that's called AE-bus. It's our proprietary CAN network that allows you to basically, combine batteries into a singular operating block up to 20 nodes at a time. So we can have, up to 140 kilowatt hours of our batteries combined on AE-bus, and then basically take an extension from that, denoting any one of those batteries to be a ZAMBUS battery, and then we would speak, all those batteries would collaborate and speak and be broadcast over the ZAMBUS network. Just a quick pictorial for you to see what we mean when we mean closed loop, but in I guess, short sense, it's simply the fact that our battery is communicating directly and able to have bidirectional communication, either leader follower or follower leader, depending on the action that it's taking at a given time. Okay, we auto-populate the battery set points as soon as it's plugged into that network. We also allow for full data logging and review and fault and warning analysis and history and things like that on the Insight portal. Eric will give us a demonstration of that at the conclusion of the presentation. And again, we can do neat things like dynamic charge controlling, where we basically push the voltage settings through bulk and absorb to optimize the charging profile for the batteries, optimizing for time, optimizing for cell balancing, and optimizing for health. Okay, so that's just what we mean when we say closed loop. If you don't want to close the loop with the batteries, we still meet the 9540 requirement. It's not a hard requirement to have. It's just a feature that is very, very useful for people operating a system like this, and really brings the two platforms interoperability into play. Okay, next slide, Matthew. Okay, and it's just a quick note on sizing here, because you saw the different sizes of the batteries. You may wonder why, let's say, one of our 3 kilowatt batteries can't be singularly installed with a 6848. The answer in the short case is that it could, but you'd have to derate the 6848 and not get the full benefit of its output. So, as you can see here, I have the continuous ratings and the peak ratings in for both the surge and or charge of the batteries there. We can do 130 amps with our battery in terms of charge. So one battery, yes, it can work 1-to-1 with the 6848, but you'd have to reduce the charge output max on the 6848 to 130 amps. That's 1C. It's a 130 amp hour battery. Okay, so generally speaking, if you don't want to derate it, it's 2 batteries minimum of the big one, and you would need to have 3 batteries or 9 kilowatts for the least amount of storage, we're using the 3 kilowatt battery. Okay, and it's just basically a factor of matching the amp capabilities of the battery to the amperage output and or input draw of the inverter chargers. Okay, and that's why that matrix is designed the way it is. You could make a smaller system, again, one 7.4 battery to one 6848, and I'm sure you would have zero issue getting 9540 permitted on that, provided, you know, from an operation sense that you just derated the charger by 10 amps to 130 amps. Okay, these are types of things that are generally novel to solar installers that had experience in the lead acid world, because with lead there was really no limitation on current handling. That was never a bottleneck. With electronic batteries and a BMS, even if you build them as big and robustly as we do with our BMS, which is, you know, has industry leading current capability, there are still limitations that are usually restrict sizing to current handling rather than capacity. Okay, if there's no questions now related to our batteries, Matthew, we can move on to the next. This is Eric, over to you on this one.
Yeah, so Discover battery, as you're well aware, has been used with XW going back to the XW Plus days. We've always been able to be direct compatible through ZAMBUS. We can be AC coupled or DC coupled. Now with UL 9540, that hasn't changed. So systems above 20 kilowatt hours may qualify. That's going to be AHJ specific. Closed loop communication is a nice to have, and certainly it can contribute to the longevity of your storage system. For example, since the BMS does communicate and automatically sets up the XW devices, the charging profiles, the battery type is custom, you know, and it will make adjustments over time. I have a Discover battery with a single XW Pro here at my home. And, you know, for 4 years, this battery is 4 years old, you know, so you talk about the battery voltage being fixed and controllable by the BMS. So I recall when I first installed the system, it was charging it right around 57.6. And now we're right at about 57. So only about a half a volt difference in 4 years. So there's not a whole lot of adjustment going on. The main issue is the cell temperature, which really has never changed. This battery is always at a rock solid 22 to 25 C, depending on the ambient temperature of my service entrance. But the most popular aspect of closed loop with customers and installers that I've spoken with is just the plug and play, right? You don't have to go through and you know, manually enter any values. You plug it in, the Discover battery sets itself up, and then you move on to programming the system for how you want to use it, whether it's off grid or on grid with grid support or load shave or whatever. Then of course, settings, the lithium ion battery solution guide or ZAMBUS integration guide from Discover. So again, if you're on ZAMBUS, it's plug and play. You don't have to do anything. If you are using Discover Link, then you do have to set it up for the Pro up for external BMS. So there is a little bit of programming required for that one. Next slide.
Yeah, let's get into the inverter charger.
So just an overview of our suite of products. We believe at Schneider Electric that designing around the needs of the customer is the path to success. In my mind, there's no such thing as an all-in-one. If you know, especially when it comes to residential solar with storage, one size definitely does not fit all. There's a wide range of applications with different requirements. So when you have a scalable system such as this, designing around the needs of the customer, we believe offers the best path to success for your business as an installer, as well as ending up with the happiest customer. So we offer 3 solar charge controllers for DC coupling. We have the MPPT 6150, which is a passively cooled 60 amp charge controller with a maximum PV input voltage of 150 volts. And then we have 2 models of high voltage solar charge controllers, the MPPT 80 and MPPT 100, which offer 80 and 100 amps of charging current respectively, with a maximum PV input voltage of 600 volts DC. And of course, we have our edge devices for monitoring inside home and inside facility. Inside home is a smaller, more cost-effective solution with a single ZAMBUS network, and inside facility has 2 ZAMBUS networks for larger systems. Then of course we have inside cloud. The value for that is remote monitoring, among other things. Data logging, push to the cloud. You'll get push notifications, as well as inside mobile, so you can see what's going on with your system from your mobile device. Then, of course, for those of you that are interested in using batteries that are not directly compatible, such as Discover, we have our battery monitor for open loop communication to accurately convey the state of charge of your storage system for state of charge control. And of course, we have our balance of systems, PDP, full-size PDP, which can accommodate breakers for up to 3 XW Pros. And then our mini PDP is for single inverter systems only. Config tool allows the exceptional installer to calibrate AC voltages for multi-unit systems, and also save configuration files for quick and easy configuration of cookie cutter systems. And then we also have our disconnect RS for our charge controllers to provide arc fault and rapid shutdown requirements for rooftop solar according to NEC 690.11 and 690.12. And then last but not least, we have our automatic generator start module for starting and stopping a generator according to triggers such as low battery voltage or low battery state of charge. Next slide. So XW Pro is the latest and greatest for smart grid functionality. We have taken our basic, reliable, and robust and scalable platform to a whole new level. We still have the same power electronics design and isolated compartment for airflow that adds to the longevity of the product, but we have a completely new redesigned control board that offers UL 1741 SA compliance and is compatible with many utility requirements across the North America, such as Rule 21 in California, HECO in Hawaii, and PREPA for Puerto Rico, and ISO NE for New England. It offers seamless transition, best in class transfer time of any inverter on the market, down to 8 milliseconds, which is virtually unnoticeable when it shifts to backup. One of the biggest features is we have 2 input ports, one for grid and one for generator. It's a field proven product, so we still have thousands of legacy XWs that are still in operation today after over a decade. So when you talk about a 10-year warranty, we have the goods to back it up. Not everybody can say that because they haven't been on the market that long. Next slide. And so, David, is this something you wanted to go ahead and cover what's available on your website, and then what's available on our website?
Just quickly for you guys, because you're going to be getting this sent out as a presentation in a PDF format after, I just wanted to note some of the assets that are available for you and give you some shortcuts to them. So these will be live hyperlinks in the PDF you receive. On the Discover battery side, we have the main product page where you can find out everything related to documentation, manuals, specs, anything like that related to our AES batteries. Our direct link to the certificate of compliance, in case you as installers are going to be, presenting to an inspector anytime soon, suggest you just print off a copy of that, keep it in your, vendor documentation file, and you can provide it on request. We have a link to our closed loop integration guide with the Schneider power electronics, so you can see all of the set points, the installation requirements, network terminations, block diagrams, battery install diagrams, etc., for how to complete that work. And then finally, a link to the AES dashboard page, which is the method by which you can connect using software on a PC directly to the batteries and pull data logs, upload new firmware, do diagnostics, etc. There, it's just basically, you know, a link to a bunch of video tutorials and the documentation and the most current firmware and software revs right there. On the Schneider side, similarly, they have the UL 9540 application note. There they have a certificate of compliance on that site as well. You can print it off. Their duplicates for either organization, so whatever is your pleasure. And then they have done a really nice job, Jack and Eric, of doing the lithium-ion battery solution guide, which I think is quite comprehensive and a very useful tool. You know, I actually wish these were more broadly circulated and distributed because it's quite a handy tool. But these are just links for you guys afterwards. You don't need to be copying anything down or furiously looking on your own. These are hyperlinks. It'll take you direct to the source for any of these bits of information, and that's the only intention of this page. If you want to skip the next one, Matthew, we'll let Eric go on here. So this is the portion of our show today where Eric is going to dump in sort of, I guess, parallel here. He's going to show you a view of his home system through live login to the Insight portal, and then basically demonstrate to you the use case or the you know, operation state of these different systems and the different system capabilities in different use states. So without further ado, Eric, over to you.
All right, thank you, David. So basically, I've got Insight Local here at my house, and this is a single XW Pro 6848 with high voltage charge controller. I have a 2.6 kW array, which is about all I could fit on my south-facing roof space. Here you can see the system in real time. So got about 1.5, 1.6 kW of PV flowing. The batteries are remaining full, and I've got about 300 watts worth of load, and I'm exporting 1.5 kW back to the grid. So this is what we call enhanced grid operation, where the system waits until the batteries are fully charged, and then we go ahead and start selling back to the grid. So enhanced grid mode means we're prioritizing a full charge, and we're also following the output in cell mode according to what's being produced by the charge controller, and we're keeping the battery topped off. So you might ask, well, why do you have two batteries there? So I'm doing some testing right now with the battery monitor side by side with Discover Link. So this is what Discover Link shows up as in your ZAMBUS network. It says SE CAN BMS. It communicates over CAN with the Insight Home or Insight Facility, whichever edge device that you choose. And then you can see you have all the metrics here, the voltage, the current settings, as well as battery temperature, the state of charge, as well as state of health. So all these things. And then of course, you know, I have the battery monitor set up as well. So they really follow each other quite well. You know, the benefit obviously is having the closed loop communication with the Discover battery. But if you look at the two graphs for battery 1 and battery 2, they're really virtually identical. So going back to the XW Pro, you can see here that for the configuration, we go into advanced settings, and then we go into battery settings. And you can see we select lithium ion for use with the link. If I was just to use the ZAMBUS port, it would configure itself as custom. With the link, you configure for lithium ion, you set your charge cycle to external BMS, and then last but not least, you have your BMS settings, which you have to use the guide to manually enter these, and then you're done. Nothing more to do after that. And then of course, I wanted to also show you see if I can minimize this here. I wanted to show you the cloud as well, and what you'll see or expect to see through remote access. So here's the same system, and you can see that we have the ability to access each device and their configuration menu. And this is really a huge benefit, because a lot of times you might find that it's necessary to make some fine tuning adjustments to a system. And this can be done from the comfort of your own office, just by going in and accessing these settings for the individual devices. So, no more having to truck roll. In many cases, if there is an issue that needs to be addressed, then you can do that remotely. And let me see. There was some other slides that I wanted to kind of go over with you. Let me shrink this and slideshow. All right. Hopefully you can see that without any issues. So here we have a dual XW Pro
Eric,
system.
sorry, it's just showing your preview slides, not the actual slides themselves with the animation.
Yeah, go to the presentation mode, Eric.
Let's see, where is presentation?
Just underneath where you see the screen, full edge versus like a monitor. Beside the looking glass, there you go. You're right over it. Oh, you were over it. Now you got it.
Okay. Can you see it now?
No, we're seeing the wrong screen.
Yeah.
Oh, did you want to go back? Did you want to go back and you can go ahead and I'll stop sharing. And
yeah, why don't we just go on to the Q&A from here, because I know we're starting to run out of time.
Yep.
Unless you wanted to pull up the PowerPoint on your end, it has the same slides. Are we going till 12:30, guys, or are we going till 12?
Just till 12.
Okay. Yeah, we can take Q&A. That's fine. If you
We started at 12, just so we're clear on that one. I don't want to be a stickler.
Yes.
I'm
I don't want to
sorry,
be a
1.
stickler for clocks.
I thought
but,
it was 1 to 1:30. I mean 12 to 1:30. But
I'm free and clear through 1:30. So if you want to stay on, if there's still people that have questions and we want to keep going, I'm tracking till 1:30 is fine. After that, I'm going to eat my arm off.
There are some questions here, so why don't we go through some questions, and then if there's some more time at the end, we can go through your stuff there, Eric, because I think we've got a few.
Sure,
things.
Absolutely. Yeah, if I can make it work.
But I guess first and foremost, a comment we had from somebody on the call just wanting us to reiterate how easy it is to commission a system with the XW Pro with the 7.4 AES battery, and just how easy it is to actually configure. So that was just a comment from somebody. So that's great.
It's plug and play. With the 6650 battery has a ZAMBUS port. All you do is add that into the ZAMBUS network and you're done. It configures itself.
In the times that we've reviewed support calls and doing that kind of stuff, I mean, the biggest thing for anybody who's, let's say, coming to the world of networked devices is understanding the fundamentals of a CAN network. And that's basically that each end has to be terminated, whether that's through a physical terminator or a terminated port on the end of devices. So, that would be probably the single biggest thing that I've seen from a troubleshooting perspective or a point of failure, particularly with ganging our batteries together. If let's just, for the round numbers, let's say you had 10 of our batteries and you wanted to have a battery bank of 74 kilowatt hours, and you daisy chain your Cat 5, Cat 6 cables from port to port through the batteries. What I see quite often is people will forget to terminate either end and just put the cable into there rather than a splitter and the termination, and in which case it can cause some unexpected results. The most common way to look and conclude that you've terminated the network properly, from my understanding, and because we do populate those settings, is that if you know that each of our batteries is 130 amp hours and you have 10 of them connected, when you look on the SCP or through your insight at the battery capacity rating, once our batteries are plugged in, it should simply read, you know, N, the number of batteries times 130 amp hours capacity. So in this case, 1300 amp hours. And if you've done that, you know your network's terminated. And I would imagine from, you know, Eric and Jack's perspective too, I mean, network termination probably still to this day is, you know, a troubleshooting gotcha that's
it's
regularly
important.
occurs.
Yep, it is important. And it's also worth noting that multiple Discover batteries does not contribute more ZAMBUS traffic than a single battery. As David mentioned, it aggregates the number of batteries and it automatically populates the new capacity, right? So we're not talking about you know, only being able to fit a certain number of batteries into a ZAMBUS network. It's also worth noting that Inside Home is internally terminated with a single ZAMBUS port on it. So you only need one terminator at the other end of the network.
Yeah, and again, for most people, you know, unless they know that a device is terminated and things, what I usually recommend, because some of the network cable connections due to, you know, regulation on AC devices and things like that with the Schneider pieces, when you plug in the RJ45 port, it's actually shielded by a cover plate afterwards. So it's hard to just look at it and visually assess. So, you know, if you know that the Insight is terminated on one end of your network, that's a good natural device to have at the end of the ZAMBUS network. And then on the other side, if you want to put our batteries where you can see the physical termination in the splitter to denote that, then you can just visually assess, you know, is my network, my ZAMBUS network terminated? Yes. You know, it's, I can see the terminator at the battery and I know that the Insight home device is terminated. So it's done. You know, that's it. Just, there's some little gotchas there and things like that, but that's pretty much it. You know, again, because we control the charge voltage, the biggest concern I would think for anybody that's commissioning a lithium battery with any power electronics in general is configuring it, the power electronics, for proper charging. And I'll, not to pick on them or anything like that, but because let's say midnight charge controllers don't have any comms capability with our battery, right? We recommend, let's say, a bulk charge of 54.4 and a float charge of 53.6. Well, you can't just set a midnight charge controller for 54.4 volts and assume that's what it's going to see at the battery terminals. There's some calibration issues and the like there. So if you don't have closed loop, it means you have to do a whole bunch more work at commissioning to make sure that it's configured correctly. And quite often, you know, and then there's, and I don't want to name names. I actually feel bad for even picking on the midnight guys at this point in time. But, you know, if it's an open loop system where you have no ability to communicate between the devices, you're left on your own to do that configuration. So, you know, you might start at setting your charge controller for 54.4, and then you have to pull the data logs from the battery after a charge cycle and see what was actually achieved at the terminals, and either scale that up by a half a volt or a tenth of a volt or whatever the difference is to make sure that it's calibrated properly. You know, to account for losses, to account for, you know, voltage regulation of that particular device or whatever. It just, you know, not to mention that, but I mean, when you're driving a car, it makes, you know, you're looking at your dashboard, it does you no good to just see a fuel tank empty full. You know, it's nice to see your fuel tank in relation to your RPM, to your speed, to your kilometers driven, you know, to your engine temp. And in effectively in doing that and closing the loop between our battery and the power electronics, when you look at Insight, either locally or through the cloud, you are seeing a dashboard that's a representation of your entire systems operation rather than just the battery or rather than just the inverter. And it makes your experience or your understanding of what's going on all the better.
Okay, well, here we have another question. Why do you estimate SOC from voltage instead of using dead reckoning?
Oh,
Well,
okay.
Well, that's a Discover question, I would take it.
Yeah, I think they're asking that within context of within our BMS, how we're assessing SOC.
Okay. Yeah.
Right. Otherwise, if the question is at the power electronics level, we're actually broadcasting the SOC metric. So that's coming from our BMS. We're broadcasting that. Why do we use it? I don't know. That'd be a good question. And I actually did a question for Eric Wilson, in fact. But, you know, I can tell you that the algorithm we use is in relation to discharge current at the time. It's not simply from voltage, it's from discharge overall, shunted monitoring. It's from the rate of discharge, and it's from the voltage at a cell level. And then obviously the cell block average, actually each cell series stack of cells, and then the cell block as an average. So there's an algorithmic interpretation there, and it is very, very accurate. It also, again, it's load dependent. So it's, our SOC and rate thereof is determined differently at different stages of charge.
That's actually a good question, David. And, our battery monitor acts as a true Coulomb counter to track the current in and out of the battery. And as I showed you earlier, we have mirror images of the state of charge between the Discover battery and our battery monitor. So they're both really very, very accurate. Now, I've worked with Eric Wilson pretty extensively in the past and asked a lot of
for those of you who
questions
don't know,
about
Eric's our
battery.
head of engineering. Yeah.
Yeah. And, the way he explained it to me is the voltage is only used when you first power up the battery to just approximate what the battery's state of charge is, but it then goes into an active algorithm to determine the true state of charge after you get some power flowing.
Yeah, there are over 400 in the 7.4 kilowatt battery. There are over 400. I can't remember the number. It's a multiplication by 16, but there's over 400 individual cells in there, ranged into basically blocks that are 16 blocks, cell blocks that are acting as those cells or cell modules. We're temperature managing, we are cell balance managing between all of those different blocks at the cell level. So there's a lot of data going on there that we can base very accurate algorithms on. And in fact, to Eric's point about the battery monitor, when we are plugged into ZAMBUS, we're emulating two devices. We emulate the battery monitor because it has PGNs related to SOC and battery temperature and things like that. And then we also emulate the diagnostic tool, which is what we use to do the dynamic charge configuration and change the voltage settings throughout the charge cycle. So there's a lot going on in that BMS. And, again, we're on our 4th generation of BMS right now. So the algorithms are tight.
Let's keep going. We have some more questions here. And just maybe this is a really quick one. What's the float voltage for open loop system, David? You mentioned it, I think.
The flow voltage at our battery terminals that we want to see is 53.6. If you are configuring that from a charge controller, my general suggestion to you, unless you're using, let's say, actually the Schneider Electric charge controller, especially the 80 and the 100, if you're using them open loop, you can basically set them for 53.6 and accommodate for any voltage drop that you might see. If you're using an FM 100 from Outback, you can pretty much take that as it wrote and just account for losses that way. If you're using anything else, my suggestion is to start a 0.5 volt higher and then do the calibration exercise in our open loop guide, where basically you set it original settings and then you look at a charge cycle, pull the data logs and see what the actual terminal voltage was during float, and then tweak it upward. And you would do the same factor for the bulk charging as well.
Okay, back to a 9540 question. So do you anticipate any carve-outs under UL 9540 to allow for systems that were designed, built, and inspected before certification was established?
Michael Gulo, you are exempt. It does not, it's a grandfathered system. So if you've been in and permitted, you are good until you decide to move that system to a new home.
Awesome. Question for Discover here again. If someone's looking for technical assistance, who do they contact?
Depends on whether it's Schneider stuff or Discover stuff.
I'm assuming it's Discover.
The best way, and this is, it's the facts of modern call centers and support systems, right? Everything that we want to do in terms of providing support is tracked and logged within a case. Okay, the initial step for anyone who wants support with our batteries is to initiate a case. You go to our website and under the support tab, you do contact support. You fill out the form that's there. That'll generate a case and give you a confirmation email with better regularity than you get confirmation emails from our webinar, by the way. And after that, you have a case number that is trackable and traceable. You know, obviously we were going to try with some of the built-in documentation and the FAQ type stuff that's basically cut and paste responses to dig in and resolve your issue just through email as quick as we can. If it is an escalation point required, though, that the calls and any subsequent call to site will be, you know, brought from that system and be attached to that case, so we have a long record of it, and that any one of our tech support reps can pick up the case and handle it through because they have all the background documentation there. That is just the standard process for any modern support, call center, if you will. You know, you basically track everything, give it a unique ID by case number or what have you, and then follow it through that way.
Maybe we should afford the same luxury to Schneider Electric. If someone's looking for support, how do they do that?
Yeah, absolutely. I think it's really a great question, because we have, we've actually expended significant resources toward a brand new tech support team. So no more waiting on hold or no more getting callbacks from the team. Somebody is going to answer the phone now. No more tying up the really experienced guys with the simple questions. We have 3 levels. We have level 1 for the end users. We have level 2 for the installers. And then if anything gets past the level 2, it'll go up to level 3 to talk to the really seasoned guys. So there's no reason why anybody would have to, require tech support and not get their questions answered anymore.
Yeah. In fact, we just did a recent test and the average wait time is 30 seconds now. So that's really, really good.
Mm-hmm.
Awesome. Some more questions here. On a system with multiple 6848 inverters, does each inverter have a grid connection, or is it just on a single inverter?
So each inverter has a grid connection and it has a separate generator connection. So each inverter is smart enough to know when the grid returns, so it'll do an orderly stopping of the generator. Yeah, that's one of the benefits that we have over a lot of the competition is the fact that we can support both grid and generator. The grid connection can sell back to the grid. The generator connection can do generator support and generator related functions. So yeah, it's really important to be able to have delineation between how you're behaving with the AC source, right? Because if you are AC coupled with a generator, you definitely don't want to be exporting PV power in an effort to turn the armature of that generator backwards. You need to protect that generator from that type of behavior. So that's why DC coupling with a generator, to me, is probably the optimal solution. But you can do both. We can AC couple with generators. We can DC couple with generators.
Yeah, and one other huge benefit is because we have that second generator specific port, we can synchronize with just about any generator and use that generator to charge our batteries. Most of the companies out there really have trouble synchronizing with generator and charging the batteries with the generator power.
So got a few more questions here. So if leaving home for a few weeks with an off-grid system, what do you recommend for keeping Discover batteries from crashing or overcharging? I think that's to you, David.
Oh, sorry, say it again, please. I just didn't try to, I was reading another cute question.
Yeah, if leaving home for a few weeks with an off-grid system, what do you recommend for keeping Discover batteries from crashing or overcharging?
I recommend using closed loop communications integration with Schneider Electric pieces and then leaving in good faith. You know, get a cheap flight, book a place in the sun. I would recommend, leave your heaters off and any big loads off, so you're not unnecessarily dragging it down, but there is no overcharge or anything like that. That's just not going to happen.
Great. So there's a couple of questions talking a little bit about temperature. So I'm going to try and see if I can get these questions here at the same time. So what are the limits for ambient low temperature? And can you recharge in a remote location during winter with no heating? And secondly, I think just to build on that question is, does the BMS shut down charging when the battery is exposed to below freezing temperatures, or does it need to be managed separately?
So if the cell block, and this is important to say, it's not the external or ambient temperature, it's the temperature within the cell block that we're looking at. And when I talk about temps, okay, you can damage ferrophosphate or most lithium cells if you're charging them below 0 degrees C at that cell level. That said, we do have software built in and controls built in. What you would have is you would have a under temperature UTP fault would happen at under temperature protection, as opposed to HTP, which would be high temp protection. And essentially we would just open the circuit, allowing no discharge or charge from the battery. The way, if that ever happened, most of our faults and warnings are auto recoverable. However, that would only auto recover if the ambient temperature inside, the cell block temperature rose above the zero threshold, with some hysteresis. And I want to say there's about 2 to 4 degree hysteresis on that for recovery. And we would only open after it was achieved that way. So you'd either have to, light a fire, turn on the heat, turn on your furnace, whatever you do for heating that space, and wait for the cell block to warm up to relieve it. That's the batteries will protect themselves at all costs. That BMS is solely on that cell block to protect the cell block. So yes, we do guard against that. For long-term extended shutdowns, if you had, let's say, a remote cabin or cottage and you were going to be leaving it for the season and it's going there, I'm going to either shut it down, the storage temperature is very low, and just shut the whole system down and let it be so there's no current at it. Or if you have a charging source the whole winter and you have some means of external heat, whether that's thermal, solar thermal, whether that is some kind of a load bank in there in a well-insulated room, or if you're running loads regularly. I mean, you got to keep in mind, the inverter charge is about 93% efficient, so 7% goes to heat. The batteries are 95 plus, so there's another 5%, there that can create enough heat in a well-insulated room to keep it thermally fine anyway. It all matters to the sort of the extents that you're going to. But external, I know a lot of the extreme external containerized systems that might be operating for, say, Homeland Security or the DoD, or telemetry stations and things that are remote tops. They typically have some kind of an HVAC system, whether that's from heat mats, whether it's from a compression system or what have you, some means of maintaining the temperature within that outside or within the operating parameters of the devices.
Yeah, we used to have heater options for our utility scale inverters when we were in that business. But as far as XW Pro, the data, the data sheet says minus 13 Fahrenheit all the way up to 158 degrees Fahrenheit is the operating temperature range. I'm sure that Discover has their own data sheet for their maximum and minimum ambient temperatures.
Not ambient. It's all cell block reading.
Yeah,
right? It's a large thermal mass. You're talking about 200-pound battery there. So if it gets to minus 10 at night, but it's only you got 10 batteries in a reasonable room, it's not going to probably approach the zero threshold you need to worry about.
Yeah, we've got a lot of systems installed up in Fairbanks, Alaska, which I was there in winter one time, and I don't know how cold it was, but it felt like absolute zero. It was frigid. It's well below zero.
Yeah, for Canadian winters, that's just called standard. just winter.
It was Manitoba. Yeah.
Question for Schneider is: are there any software updates planned for Insight Cloud?
Sure, we're continually updating, the cloud, and we're continually improving and adding features to our devices, whether it be Insight Local or XW Pro. The charge controllers pretty much haven't had firmware upgrades for quite some time. I think we've reached a level where we don't have to do sustaining engineering on those, but we're continually offering features and improvements to the Pro, and will be for the foreseeable future.
And Eric, I think on the cloud, so it's specific to that, there are software updates happening there all the time, but that's not a firmware upgrade.
You're just, right, that happens behind the scenes. Right.
Yeah.
Great.
And again, to be clear, if you're looking at something on the cloud, there's no software update to that. That's
Right.
behind
Correct.
the scenes. You're just looking at that
Exactly.
through
That's us
a
behind
web
the
address.
scenes making updates, and so your view is going to change regardless of what you do to your system as we add features, functions, whatnot.
That's right.
Great. Well, there's no more questions. We've got one that came in early from Mark Robinson, speaking specifically to his system there. So I think unless we have anything else come in here before I stop talking, I'm going to stop the recording. If anybody wants to stick around, and I think if so long as Jack and Eric and David are okay, we can certainly answer your questions, Mark, and open it up further. But otherwise, I don't see any other questions. So I'd just like to thank all of you for joining our webinar today. Thanks to our presenters. And as a reminder, we will be sending out a copy of the slide deck today, as well as the recording of the webinar to everybody who's been in attendance.
Hey,
So,
just a quick call out here, because I saw it in the chat and I didn't realize he was on, but to James McPhail and the guys from Hackeye, I want to say big props for the cool image that I pirate from you all the time, the microgrid that's behind us, the containerized system, that's their work. Anyhow,
Cool.
thanks very much to all of our partners and things, whether you're installers in the field or resellers and the like. Again, thanks very much to Eric and Jack. Great to work with you guys again and again and again.
Yeah. Thanks, everybody.
Thanks, everybody.
all right, so I'm going to stop our recording.